There is a small brown bird in the forests of Australia. He is not large. He is not colourful. He does not have an impressive wingspan or a powerful call, or any of the features that make birds famous. He is, by most measures, completely ordinary. Except for what he does every morning. Every morning, he goes to work. He collects objects, blue ones specifically, bottle caps, berries, feathers, pieces of plastic, flowers, shells, anything blue he can find within his territory. He carries them one by one to a specific location he has chosen and prepared. He arranges them, not randomly. He places the smallest objects at the front and the largest at the back. He steps back and looks. He moves something 2 centimeters to the left. He looks again. He moves it back. He is arranging his collection according to the laws of perspective. The smallest objects in front create a forced perspective effect. When a female approaches from the correct angle, she sees a visually compressed field in which the male appears significantly larger than he actually is. He is using optical illusion to make himself look bigger. And then the researchers did something that changed everything. They came in the night and reversed his arrangement. Largest in front, smallest in back. They hid and waited. The bird returned in the morning, walked to his gallery, looked at the arrangement, and immediately began putting everything back exactly as it had been. Every object. Correct size order, correct position. He knew it was wrong. He knew what right looked like, and he fixed it. The researchers sat in silence for a long time, because what they had just documented was not instinct. Instinct does not have an opinion about whether the arrangement is correct. This bird did. This is the story of the bowerbird, the only non-human animal on Earth documented deliberately using perspective to create a visual illusion, and the science behind what his gallery reveals about the nature of intelligence itself. The builder. The great bowerbird, Chlamydera nuchalis, lives across northern Australia, from the Kimberley coast through the Northern Territory to Queensland. He is, in appearance, magnificently unremarkable. Brown-grey plumage, medium size, a small crest of pink feathers at the back of his neck, visible only when he displays. Nothing that would cause you to stop and look twice, but the bower tells you everything. A bower is not a nest. This distinction is critical and often missed. The bowerbird's bower is a structure built solely to attract a female. It has nothing to do with raising young. The female builds a separate, simple cup nest elsewhere to lay her eggs and raise her chicks. The bower is purely a performance space. The great bowerbird's bower takes a specific form. 2 parallel walls of sticks creating an avenue, roughly 50 centimeters long, oriented north-south to maximize consistent lighting throughout the day. At each end lies a court, an open area where the collected objects are displayed. The construction of the avenue alone takes weeks. The collection of objects takes months. And the arrangement of those objects, the gallery curation that is the male's true masterwork, is a continuous, ongoing process of adjustment, refinement, and correction that does not stop until the breeding season ends. He is never done. He is always editing. The gallery. In 2012, Dr. John Endler of Deakin University in Australia published a paper that sent the animal cognition world into quiet uproar. Endler and his team had been studying great bowerbirds in Queensland for several years, measuring and mapping object arrangements in multiple bowers in precise detail. the size, position, and orientation of every single object in every court. What they found was not what they expected. The objects in the court were arranged in a very specific gradient. Smaller objects at the front, near the entrance of the Bower Avenue, and progressively larger objects toward the back. So, Endler's team ran the experiment. They entered the bowers while the males were absent and scrambled the objects, removing the size gradient, placing large objects at the front, small ones at the back. Then they watched. Every male returned, every male inspected his court, and every male, without exception, restored the size gradient within days. Some were faster than others, some were more precise than others. But all of them knew the arrangement was wrong, all of them fixed it. The team then measured the perceptual effect from the female's perspective. A female entering the Bower Avenue approaches the court from a specific angle and distance, framed by the avenue walls. From this precise viewpoint, and only from this viewpoint, the size gradient creates a forced perspective effect. The field of objects appears compressed. The entire court looks smaller than it is. And the male, displaying at the far end, appears larger than he actually is. He has not arranged his objects for himself, he has arranged them for her. What forced perspective requires? To understand why this is extraordinary, it helps to understand what forced perspective actually demands of the mind that creates it. Forced perspective is the technique used in architecture, film, and stage design to make objects appear larger or smaller than they are by manipulating the viewer's spatial expectations. The Parthenon columns are slightly thicker in the middle because the architects knew the eye would perceive perfectly straight columns as thinner, so they compensated. Peter Jackson's Lord of the Rings used forced perspective to make human actors appear hobbit-sized. Disney theme parks use it on castle buildings to make structures appear taller than they are. In every case, the creator must hold two spatial models in mind simultaneously. First, how the objects actually are, their real sizes and positions. Second, how the objects will appear from a specific viewing position, the perceptual reality of the observer. The creator must understand that these two models are different and must deliberately manipulate the first to produce a specific version of the second. This requires what cognitive scientists call allocentric spatial reasoning, the ability to model space from a viewpoint other than your own. It requires theory of mind, the understanding that another creature will perceive the world differently than you do. It requires aesthetic intention, the decision that the illusion should look a specific way, the internal standard against which the arrangement is judged and corrected. And it requires exactly what the Queensland bowerbirds demonstrated, knowing when the arrangement is wrong. The artists. But the perspective illusion is only one dimension of the bowerbird's cognitive complexity. The collection itself tells another story. Great bowerbirds collect almost exclusively blue objects. The preference is not absolute. They will incorporate grey, green, or white in smaller numbers, but blue is clearly the primary aesthetic target. They are not simply collecting anything shiny or novel. They have an aesthetic preference, and they defend it. If a blue object is taken from a bower, the owner notices immediately and seeks to replace it. Males have been documented traveling up to 2 kilometers from their bower to retrieve a specific type of blue object identified in another bird's territory. They also steal. Bowerbird males systematically raid each other's bowers, taking not random objects, but specifically the highest quality items, the most intensely blue, the largest, the rarest. This requires assessment. To steal the best object from a rival's collection, you must evaluate that collection against your own and identify what you lack. You must have a standard. And then there is the decoration of the avenue walls themselves. Males chew berries and apply the pigment to the interior walls, essentially painting them. The color applied is most often a purple-blue that enhances the overall aesthetic of the bower space. A bird, painting walls. With pigment it has processed from natural materials to create a specific color effect in an enclosed space it has designed. The female's role. The female bowerbird is, in evolutionary terms, the reason all of this exists. She is the audience. She is also, in a very real sense, the art critic. Female great bowerbirds visit multiple bowers during the breeding season. They inspect each one. They assess the quality of construction, the richness of the collection, the completeness of the perspective illusion, the precision of the gradient, and they choose. The males with the most accurate perspective gradients, the ones whose arrangement creates the most compelling visual illusion, mate more often than males with less precise arrangements. Endler's team measured this directly. The correlation between gradient precision and mating success is statistically significant and robust. The female is selecting for a specific cognitive ability, not strength, not size, not colorful plumage. The male is, remember, almost entirely brown-gray. She is selecting for the male who is best at spatial reasoning, the male who most accurately understands her viewing position and calibrates his gallery for it. She is selecting for perspective-taking ability. She is selecting for theory of mind. Mate selection as cognitive evaluation. The bower is a test, and the female is the examiner. What she is testing for is, functionally, a measure of intelligence. The experiment that confirmed it. After the initial 2012 paper, researchers designed follow-up experiments to test whether the perspective illusion was truly intentional or explainable by simpler mechanisms. Researchers introduced naive males, young birds who had never built bowers, to artificial structures with controlled object sets. These naive males, with no prior bower building experience and no feedback from females, spontaneously began adjusting object arrangements towards size gradients within their first building season. The capacity was innate, but it was not fixed. Experienced males had significantly more accurate gradients than naive ones. The ability existed in every bird, but was refined by practice, feedback, and years of building and watching and adjusting. Like any skill. In another experiment, researchers placed mirrors at the bower entrance so the male, standing in his display position, could see his own appearance from the female's viewing angle. The males with access to this feedback produced significantly more accurate gradients in the following breeding season. They had seen themselves from her perspective, and they had used that information to improve. The cognitive picture. Assemble everything the research has documented, and a cognitive picture emerges that is extraordinary for a bird that weighs less than 200 grams. Allocentric spatial reasoning. Modeling space from a viewpoint other than your own, demonstrated through forced perspective construction. Theory of mind. Understanding that another individual perceives the world differently from your position, demonstrated through calibration of the gallery for the female's specific viewpoint. Aesthetic preference. Consistent selection of blue objects, application of pigment to walls, precise quality standards applied to collection items. Error detection. Immediate recognition that a scrambled arrangement is wrong, and systematic correction of every displaced object. Learning and improvement. Refinement of gradient accuracy over multiple breeding seasons. Use of visual feedback to improve performance. Social intelligence. Assessment of rival collections. Strategic theft of the best items. Competitive awareness of what you lack and where to find it. Long-term planning. The months-long project coordinated toward a single future event. The female's visit. No single one of these capacities is unique to bowerbirds, but no other non-human animal outside of humans and possibly great apes has been documented combining all of them in a single purposive behavior. And the great bowerbird does it alone, without a teacher, without a blueprint, with a brain the size of a walnut. The question nobody asked. Here is the thing that the science papers don't quite say directly. They describe the perspective illusion, they document the gradient precision, they measure the mating success correlation, they run the scrambling experiments, they draw careful conclusions about cognitive capacity. What they don't quite say, what the data keeps implying without the papers stating it, is this. The bowerbird has aesthetic taste. Not just preference, not just pattern recognition, not just gradient production. Taste. He has a vision for what his gallery should look like. He knows when it has been violated. He knows when it is right. He stands back and looks at his work, and he makes it better. When Endler's team interviewed bowerbird researchers informally in the notes that don't make it into peer-reviewed papers, several described the same experience. Watching a male work on his bower, you forget he is a bird. You watch him pick up an object, place it, study it from multiple angles, adjust it, study it again, and you see something that has no scientific name, but has a very old human name. Craftsmanship. The care a maker takes when what they are making matters to them. The great bowerbird has never read an art theory textbook. He has never visited a museum. He has never been taught the laws of perspective by anyone. He arrived at them himself, alone, in a forest in northern Australia, for the purpose of impressing one small brown bird who would visit his gallery for approximately 10 minutes before deciding his fate. And he gets it right. Every season. Better than last season. Next week on Raven Mind. The bird that hasn't landed in 10 years, and how it sleeps while flying. Subscribe, and next time you visit a gallery or a museum or a beautifully designed space, think about a small brown bird in a Queensland forest, standing back from his work, looking, adjusting something 2 centimeters to the left, looking again, getting it right.